Hello everybody, I'm Dan. Welcome to my Java tutorial series. Throughout my tutorials I will teach you Java using just Notepad and the command prompt. The order in which my tutorials are organized on both my website at javacjava.com and my YouTube playlist is designed to maximize learning by building on concepts from prior tutorials. This tutorial is about bounded type parameters. And of course that relates to the generics. General. Let's go ahead and open up my web browser to my website, javacjava.com. I'm going to select begin and scroll down here to the bounded types. In this tutorial I will introduce you to bounded type parameters. I will expand on my example box class by turning it into a generic class that will take values from various types of classes that are subclasses of the number class. Boy, talk about classes. Classes such as integer, float, double, etc. will all be valid parameter types for this new and improved version. Bounded type parameters limit the valid type parameters to only types that are an instance of the bounded type. All right, I'm going to pop over here to the number class here, for example there. So here's the direct known subclasses of the class number. And I'm going to be using byte and double and float and integer in this particular tutorial. Those are all the those are some of the primitive wrapper classes that are too as well. So let's scroll down here. We can see that this is an abstract class number, right? And we have some abstract methods here that return, like for example, these 6 methods. We all know, well, basically, what do we know about these 6 methods? I'm going to kind of backtrack a little bit here. Well, basically, these 6 methods will be inherited by every subclass of the class number, right? So we know for sure that, for example, byte has a double value method, double has a double value method, float has a double value method, integer has a double value method, so on and so forth there, right? So what I'm going to do with my box class is I'm going to take in all of these various different values as valid input values, and I'm going to create one method in there for calculating the volume, and that's going to return a primitive double type. And basically I'll be able to calculate the volume of whole numbers or fractional numbers, right? So whereas before, we have to do a lot of work, and I'll go into a little bit more about that. But the key thing to understand with bounded type parameters is that basically by specifying the number class for the bounded type, we can only use the variable type of subclasses. All right, let me explain that a little better here. Let's pop back here. So bounded type parameters limit the valid type parameters to only types that are an instance of the bounded type. The Java keyword extends is used to specify the bounded type. So for example, I've got class box, and then I've got my opening brace bracket, or pointy brace bracket, whatever you want to call it. I usually call them chevrons, and then t, which is our variable type, and then extends number. Right? And so basically what that means is that t, when we specify that particular type there, it has to be a subclass of number or somewhere down the hierarchy, right? And then of course we've got our class body here. So in the example above, the number class is the bounded type specified after the extends keyword. The t is the type variable. The t-type variable must be a subclass of number somewhere down the hierarchy, or else a compiler error will occur. Angle brackets are also known as chevrons or diamond syntax, right? So you might hear this be like, angle brackets, chevrons, diamond syntax, all the above. You know what it means. So let's go ahead and scroll down here, highlight this stuff, Control-C to copy, or right-click and select copy. And I'm going to move my browser off screen here. I've got a shortcut to the command prompt on my desktop, but if you don't, you can create one really fast by right-clicking, selecting New Shortcut, CMD, Next, and Finish. All right, let's go ahead and open up the command prompt, type in javac, which is the Java compiler. You should see all this stuff scroll by. However, if you receive an error message, watch my tutorial on installing the Java Development Kit. You want to make sure you get that installed and configured properly before continuing. CLS to clear the screen, then CD space / CD is short for change directory, and / tells it to go to the root. I'm going to make a directory called Java using the MD command, and I've already got that folder, but if you don't, it'll go ahead and create it for you. Change directories to the Java folder. I'm going to make a directory here called generic bounded. I'm going to change directories to the generic bounded folder, and then I'm a notepad generic bounded.java. That'll be the name of my source code file, also known as a compilation unit. All right, yes, paste this stuff in here. Okay, so here is my box, my generic box class. And you'll notice I've got my type variable t extended, and then my bounded type, which is number, right? And so inside of there, the first thing I'm doing is I've got these three instance variables, length, height, and width, all of t type, right? And they're private, so it's all well encapsulated. And I've got this one constructor, takes three parameters, length, height, and width, all of t type variables. And of course, I'm setting the instance variables, length, height, and width, equal to the parameter variables up here too as well. And then the one simple get volume method here, and I'm returning, and it's a primitive double return type here on the method. So I'm returning the length.double value times height.double value times width.double value. Okay. So no matter what this gets specified as, because it extends number, we know it's going to have the double value method, and I'll just go over that one real quickly here, but bringing this back here, right? So this has double value, which will return the value of the specified number as a double, right? And this is lowercase d, so you know it's a primitive double type, okay? And we can basically specify any of these types. The variable type is any of these, all right? But you know by these being subclasses, in other words, number is the superclass of all these subclasses here. They inherit all of these methods here, and the one I'm specifically picking on is double value. All right. Just want to make sure that is 100% clear, because that's the whole point of this tutorial. All right, let's come back up here to generic bounded class, and it's got the main method at entry point. And the first thing I'm doing is I'm declaring a box1 reference variable, and it's of box integer type. And you'll hear that with generics, right? Okay, so this is a box integer, and you can think almost like box hyphen, right? So this is a box integer type, reference variable box1, and I'm setting that equal to a new instance of a box integer object, and I'm passing it these three new object values here. Now I'm saying new integer, which is the integer class, creates a new integer wrapper for the primitive integer literal, and then the second parameter and the third parameter here, right? And then on the next one, I'm doing a new box integer, box2, as the reference variable, setting that equal to a new box integer instance, and I'm specifying as the arguments 7, 2, and 10. Now, auto-boxing will essentially do the same thing as creating, three new objects here, right? This will create three new objects, auto-boxing, just like this, new integer. This could be new integer 7 in a constructor type situation there. Okay, and so these arguments will get passed into here, to these parameters here, right? And we're specifying integer as the type variable. And of course, integer, since it extends number, this will all compile just fine. All right, I'm creating a new box float, box3, passing it these values here. And of course, these are getting auto box2 as well. And I have a nice tutorial on auto boxing if that's not making a whole lot of sense, as well as a nice tutorial on primitive wrapper classes too as well. You want to make sure that you understand those two, and then this whole tutorial will make a lot more sense. Then a double, and then a byte. And so let's go ahead and come up here and run this, and then I'll talk a little bit about some other stuff here. So let's clear our screen. Java C, let's compile it. Java to run it. Okay, so we get the volume of box 1 is 90, which is 6 times 5 times 3. That looks pretty good. Let's take all the math for granted on here. The volume of box 2 is 140, box 3 127.5, box 4 373.75, and box 5 is 2090, right? So that's kind of really pretty cool. One of the things I'm going to show you about let's say for example, I wanted to create a box string, right? String is not a subclass of the number class here. So if I were to do, something like this, It's not a valid auto box anyway, but whatever. It's going to show you that the compiler is just really not going to like this at all. Box 6. There we go. Looking pretty good on that. Let's try to compile this here. Okay, so we're going to get type argument string is not within bounds of type variable t, right? Where t is a type variable, t extends number declared in class, blah, 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 right? So it's not within the bounds. So that's what it's really, it's not even going to let us compile if we did something like that when we're specifying bounded type parameters here, okay? So just wanted to show you that. All right, so let's come back up here, recompile, let's clear our screen, recompile that. There we go. Okay, so we're back to normal there. All right, now here's a question to ask yourself. What would it take for us to create a non-generic class that would allow us to do something like this? So we got an integer, a float, a double, and a byte, right? And we're passing in all those values using the wrappers there and specifying these wrapper classes here. What would it take if we didn't want this, if we wanted just a regular old non-generic class, right? Well, I'll just leave some of the code in here, right? But first thing we'd need would be a, well, let's see. We'd start off with the primitive int, right? And we want int length and height. And then we'd need some variables up here instead of type t. They would have to be int types as well, right? And maybe like I length, I width, I height, right? And then we could specify those are equal to that, right? And then we need to do the same thing, for example, like float, for example, would need its own constructor as well, right? And of course, we couldn't assign these to these variables, right? We'd need like a whole new set of these private variables up here too as well for float. And so on and so forth there, right? So you can quickly see how this would become really bloated. And then when you're double volume down here, you basically always want to return a double there. So you have to do some other calculations to convert, you know, whatever had come in from into and return that back as a double. Like, so for example, if this came in as an integer, you'd need just that's pretty easy conversion on that. But if it came in as like a byte or a, you know, whatever, right? You could see how this would quickly become complicated. You'd probably even need some sort of like some sort of flag saying, okay, this particular constructor got initialized, or this constructor got initialized. So then you could do like a case statement made inside of here, like, you know, if the int constructor got, you know, who knows, right? Something like private and flag, right? And so in this one here, you could basically say like flag equals 0, right? And this would get so cockamamie really quick. Flag equals 1, right? And then down here, you could do like if flag equals 0, return this, or blah, boom, or so on and so forth there, because then you'd need to know which local variables you were pulling from. So you can see how valuable it is with these generics, because we don't have to do any of that, right? We can pass in, you know, essentially a generic value and have it do just this sort of stuff. So this really saves you a lot of coding, a lot of logic. You know, there might be some problems in logic and all that stuff too as well, you know. Plus, you know, even more than just these 4 values, integer, float, double, and byte, you know, we might want to add short later on. And if you're doing that, right, well, we can already do short. We can already do that because, you know, it's a valid subclass of the number class here, right? Here's short right there, and so is long. So we don't even have to change anything. We can, with the generic, we already get that functionality right there. So As a matter of fact, it might be a neat exercise if you're so inclined to see what it would take to create an ordinary class that would do just even these 4 values here, and then you could, you know, basically pass in some stuff based on whatnot there. But so anyway, I think that'll pretty much about explain what the bounded types are, right? Extends, and then your basic superclass here, and that allows these to be subclasses of those. So I'm going to go ahead and close out of this, close out of that, and that concludes this tutorial. Thanks for watching.